Hi, Lake Orion students. I'm Mrs. Hunter, and I'm going to be introducing and conducting lesson 4 of our Unit 3, Moving Thermal Energy. And up until this point, you know that we have been working on our unit challenge, also known as Cooling Hot Dogs. And your challenge is to create a dog crate that can keep dogs cool in case of a natural hazard or emergency, and they need to be in those crates. So we've been learning about temperature and thermal energy the last few weeks together, and today we're going to see how temperature, or what factors affect temperature in a system. So I'm going to be demonstrating the lab that you would have been able to do with your teachers in your classroom. So our materials will be using some vegetable oil. We'll be comparing vegetable oil and water using one of these bad boys, a graduated cylinder. It has graduations and it's a cylinder. So this is what we'll use for measuring the amount of our liquids. We also have some thermometers, styrofoam cups, and some hex bolts. A whole bunch of hex bolts. You can see those. Voila, like that. For safety, I'm going to be using tongs because we're going to heat up our two substances using one of these little hot pots. And we have also a balance scale, digital scale. So our lesson question is, what factors affect temperature? And as we usually do, once you see the lab, I'll ask you throughout the lab actually to jot down some notes, make some predictions, and jot down some notes of maybe temperature readings that I'm coming up with and observations that you see happening as I demonstrate the lab. Before we do that though, let's talk a minute about what we've learned so far as temperature and thermal energy. So they are different, and the difference is that temperature is a reading of the average amount of kinetic energy in a system of molecules. And thermal energy is a little bit different because it is a total of the amount of kinetic energy in the molecule. So temperature being an average of the kinetic energy and thermal energy being the total. It's difficult sometimes for people to see that difference. So we'll try to clear up some of those misconceptions that you may have heard about temperature during this lab. Okay, are you excited? Look at this beautiful day. All right, let's do some science. Okay, so I have been heating up some bolts to 85 degrees Celsius, 2 bolts, and if you think about converting Fahrenheit to Celsius, or really if you just think that the Celsius scale is from 0 to 100, 100 being boiling, if I'm heating up in the hot pot the bolts to 85 degrees Celsius, then you know how hot they are. With the 2 cups, I have measured in 1 cup 50 milliliters of water, and in the second cup, my graduated cylinder, another 50 milliliters of water. So I would like you to make a prediction at this point while I get the bolts out, and if you would please jot down your prediction. Will the temperature of the water increase, decrease, or stay the same when I put the heated bolts inside, and why? What makes you say that? So temperature, will it increase, decrease, or stay the same? So we better take the starting temperature of the liquid. They've been just here under the umbrella. Should be close to room temperature. So the temperature is about 21 degrees Celsius, And the same for cup 2. So the temperature is 21 degrees Celsius. Now, in your lab report, there is a place for you to record this data, the lab chart there. So where it says starting point of the liquid, 21 degrees Celsius. All right, are you making those predictions? Jotting it down on your lab report? All right, here we go. Take out the bolts. I'm going to add 2 to cup 1. And let it work for about a minute. I'm gonna see where the other ones are. Other 4. So really think about that why, besides just saying, oh, stay the same, or get hotter, increase or decrease. What's your reasoning behind that? You know that we like to talk in evidence. Okay, so let's do... I'm going to add 4 to cup 2. And those were also heated up to 85 degrees Celsius. So a little bit difference in time, but we'll see how that changes. Does anything. Okay, so cup 1 has a thermometer. 2 volts. I'll give cup 2 an extra, what do you think, 30 seconds? It took me to get them out of the little crock pot here. So measuring for the cup with 4. Giving it the time, I'm looking up the time we've got. About a minute. Almost done. So you can see there's the 2 cups. Cup A, 2 volts. Cup B, 4 volts. They both have 50 milliliters of water. So as we're giving this reading a little bit of time to see what's going to happen with the temperature and the thermal energy, and if your predictions were correct. I want you to think about why did I put both cups 50 milliliters of water, and why did I take the temperature and make sure the water was about the same in both cups, 21 degrees Celsius, before I added the volts? Why do we do that in science? Make the samples the same in everything else except, what do we change? The number of volts between cup A and cup B. And how does that tie into our lesson question? What factors affect temperature? So I've added the same type of bolts, same amount of water, same temperature of the water, same temperature of the heated bolts, but different number of bolts. All right, looking at the time, looks like we're ready to read the temperature. See, all right, so the cup A with 2 bolts, is at 26 degrees Celsius, and cup B with 4 bolts, that's at 30 degrees Celsius. So 26 and 30. Take a minute to record that down. The cup with 2 bolts had a final temperature after about a minute was 26 degrees. And cup B, 4 bolts, 30 degrees. Remember, our initial water temperature was 21 degrees, so in your chart, what was the change in temperature? How would you find that? You take the final temperature and subtract the initial temperature, and then you know your temperature change. And then you can think about, was your prediction correct or not? All right, so that was our testing the different number of bolts in water. Let's try this cooking oil instead of water and see how that makes a difference as far as temperature change. Ready? I'm ready. All right, so we are ready for the next material, that is vegetable oil. We're going to check out how temperature is affected based on a different material from water to now cooking oil when we add the bolts to it and the heated bolts. And hey, by the way, what'd you think of that Anchor video, the super cool nickel ball video? Did you get to check that out first? That was pretty crazy, wasn't it? Have you ever seen something like that before? Sweet. So we'll talk about that more later on in the lesson. We'll come back to that Anchor video. But I have measured in cup A. I discarded the water. Cup A now has 60 milliliters of vegetable oil. And I'll add 60 milliliters. You can see that, of vegetable oil. I just used this. I'll add that to cup B. Some of you may be thinking about, what's the difference I'm doing besides this vegetable oil, not water? What did you notice is different about the volume? Maybe you caught on that previously I used 50 milliliters of water, and with vegetable oil I'm using 60 milliliters of vegetable oil. So that's a change. And in science experience, we're really not supposed to change more than one thing. I mean, we're changing the type of substance, but why are we changing also the volume? That is to consider the density of vegetable oil and the density of water. So think about your background knowledge of water and cooking oil as far as density. So to compensate for the difference in density, I changed the volume of the cooking oil, increased it a little bit, 10 milliliters, so that it's now about the same volume compared to water, just simply because it's got a different density. So I'm actually trying to keep that factor the same. And remember, what are we looking for? We're trying to figure out, by collecting some data, what factors affect temperature. And so you probably then have done the math between the previous experiment where you predicted how would the temperature change when we add the heated bolts to the water. Would it stay the same, decrease, or increase? And then I added actually more bolts in cup 2. So I doubled them to see how the temperature changed. And looking at your results between, well, first of all, did the temperature increase, decrease, or stay the same? I wish I could see your answers, but in looking at the data, then we started with 85 degrees Celsius bolts, put it in 21 degrees Celsius temperature water. The water change with 2 bolts was 5 degrees Celsius warmer, or increased, I should say, and with 4 bolts, the increase went to 9 degrees, or went up by 9 degrees Celsius to 30 degrees. The water temperature became 30 degrees Celsius. So we've got that recorded. Now let's see what happens with the cooking oil. Okay, so you will now record, please, in the space in your lab report where it says the starting temperature of the liquid for 2 and 4 of the cooking oil. The starting temperature is 22 degrees Celsius. So go ahead and write that in your data table. Starting temperature of the liquid, cooking oil, 2 and 4 both have 22 degrees Celsius temperature. All right. So in the next part of your lab where it's a prediction part of the cooking oil, I'm curious, now that we're testing the cooking oil, do you predict that the temperature difference will be about the same as the temperature difference of water when I add the bolts? Will it decrease or be less than that of the temperature change of water, or will it stay the same? So go ahead and jot down your prediction as I get out those bolts. And actually at this step I want you to make another prediction. So we're comparing cooking oil to water, predicting how will the temperature change based on the change in the substance. And part 2 prediction of the cooking oil, when I compare 2 bolts in cooking oil to 4 bolts in cooking oil, how will that differ? Or will that stay the same? So will the temperature change, increase, decrease, or stay the same between cooking oil with 2 bolts and cooking oil with 4 bolts? Go ahead and write it down. Your teachers will be seeing what you came up with when you respond. All right, so we'll get to these bad boys. Heat it up, hot. This thing is super hot. What haven't I told you yet? There's something I haven't told you about these. Yeah, there we go. Good thing it didn't splash. 2. This time I'm going to try to get the 4 in. About the same. Yeah, I know what you're thinking. Where's my goggles? Why am I not wearing goggles? That's something I didn't grab from my classroom. Safety goggles. But do not try this at home without your safety goggles. Alright, so now we're rocking and rolling. We've got cooking oil, we've got 2, we've got 4, we've got some temperature changes happening. You've made your predictions. All is copacetic. Okay. Timing it. Looking at the clocks there. Keeping it at about a minute. After this time is up, we'll record the data. And then your favorite part will be up to you. That's analyzing the data and creating a graph. We'll just have you make a bar graph in that next section. Of course, you're going to have to convert your data table to a graph so that we can analyze the results. Okay. All right. Focus on time. All right. Here. So, cup A, cooking oil, 60 milliliters with 2 bolts. Is that, wait for it, 30 degrees Celsius. And the cooking oil with the 4 bolts is, what do you think? Shout it out. What number? If 2 is 30, what do you think 4 is going to be? It said 37 degrees Celsius. So jot those down. Cup A, 2 bolts, 30 degrees Celsius. Cup B, 37 degrees Celsius. And by now you know how to do the temperature change. That last column in your chart, the change in temperature of the liquid. You take the ending temp and subtract the starting temp. So let's say we started with 22 degrees Celsius with the cooking oil cup A, and it went up to 30, so that would be a change of 8 degrees Celsius. And with 4 bolts, cup B, It was also 22 degrees, went up to 37, change, that's then a total of 15. Is that right in my head? Yeah, 15 degrees Celsius. So interesting. Because both liquids, water and the cooking oil, started about the same temperature, 21, 22 degrees. The change of water from at 2 bolts was 5 degrees. 4 bolts was 9 degrees. Cooking oil, 2 bolts, was the change was 8 degrees. 4 bolts, 15 degrees. So if we're thinking about how or what factors affect temperature, what factor in the type of material, how did the type of material like water and cooking oil make a difference in temperature? And also, what we really do between 2 and 4 bolts, we changed the amount of matter in a substance. So we'll go ahead and graph your results, and we'll be back in a minute.